hello everyone. Thank you for sticking around and joining us towards the end of a very long week here at DISTRIBUTECH, but really appreciate you all coming. I'm Caitlin Albertoli, co-founder and CEO of Buzz Solutions.
And I'm Vic Chaudhary, co-founder and CTO at Buzz Solutions.
And today we're going to talk about a case study that we've done with the New York Power Authority, transforming transmission inspections, how NYPA and Buzz Solutions are using AI to improve reliability and asset management. So just to start us off, I want to talk about who we are here at Buzz Solutions. We are a visual AI platform that launched in 2017 from Stanford University. We spent 3 years building the commercially deployable algorithms, which we will talk about today. We're active in multiple countries, working across many states, specifically supporting the electric utility industry. We're launched and headquartered in Palo Alto, and we provide an AI-powered platform that delivers actionable insights for highly accurate infrastructure inspections and monitoring. Today, we serve the transmission, distribution, substations, and solar infrastructure inspection types. And to start, I want to talk a bit about our platform, which is called Power AI. It's a software platform. I'll kind of just talk through this slide. I know there's a lot of information here, but today we are servicing the helicopter, drone, fixed wing, static camera collected data sets. We're working across multiple different types of assets: transmission, distribution, substation, solar, and we're also starting to do some work in generation. And to talk a bit about the workflow, as you'll see on the bottom gray, we provide visual data management services where we ingest the data sets collected from these variety of means of inspection types. We work with organizations like Esri to map all of those structure locations and update the information geolocated as a part of those inspections. The core of our platform is the visual AI processing, where we have dozens of pre-trained algorithms that provide a number of asset inventory and detections, as well as condition assessment models. We have a human-in-the-loop workflow, which allows subject matter experts to edit results, add labels, delete labels, or adjust severity metrics as needed. And then we are also a strong workflow solution where we plug in and integrate directly into a variety of systems that the utility may already have in place today. This includes GIS systems, asset management, work management systems, and any cloud storage buckets the utilities are working with. As you'll see below, this is a list of some of the common integrations that we work with across a variety of different utilities. And then as you'll see on the outside purple ring, these are common different types of use cases that we feed into. So it's the asset inventory and condition assessment for asset management, it's geospatial analytics, RGB and thermal data analysis. It's for storm resilience, wildfire risk mitigation, and preventative maintenance. We're also working on trend analysis as well. Now to talk a bit more about who is the New York Power Authority. They're a state-owned utility in New York. They're about 1,500 circuit miles of transmission lines, which is about 1/3 of New York State. They have 1,300 power and energy service customers, and they also have a variety of generation facilities. And so the New York Power Authority has put out a public Vision 2030 program. This is an all-encompassing overview of the Vision 2030 program as NYPA looks to become a digital utility. You can see a variety of different types of programs that are a part of that Vision 2030 program. Today, we're really going to be zooming in on NYPA's leadership as in transmission, as they look to become the leading transmission developer, owner, and operator of New York State, many of which includes the adoption of advanced robotic technologies and analytics technologies as well. To talk a bit more about their robotics program, this is a very well-funded robotics program they've been scaling over the last several years. Total missions year to date in 2025 was 1,900 inspections that they conducted as part of those missions. That number continues to increase. They have 136 pilots, 131 total systems, and as a part of these inspections, they collected 380,000 images, and that number continues to grow with each mission. This is a bit of an overview of how the information actually flows across the program. So reliability-centered maintenance is really the core of that maintenance program. Moving down, you'll see that this includes maintenance plans, spare part strategy, risk analysis, and then asset health criteria. And that flows into these different technical programs that they have that are supporting this project. It's anything from sensor strategy, robotics, which we'll be talking mostly about today, mobile apps, AI/ML, something else we'll be talking about today, and then asset information. A core part of the NYPA strategy as well has been to feed all of this information into their advancing ISOC. So central data management and insights flowing through their ISOC has been a core part of this program. And with that, I'll hand it over to Vic.
Thank you, Caitlin. So yeah, we are focusing a lot on New York Power Authority, and we want to kind of highlight what the partnership has been with them. So just to lay the groundwork, how we got involved with NYPA, what were the processes they followed, and how did they evolve these kind of systems and programs for their digital asset intelligence processes. So starting off, we went through an RFP process with NYPA. And we also like to talk about this in context to general utilities as well, that they can follow these kind of programs and processes in order to advance their robotics program. So starting off, we did an RFP where they had over 100 vendors that submitted the bid for. As part of the RFP, this is an integral part of it, which is the AI bake-off, which is great to kind of evaluate where the AI models, computer vision models are in this space, and then also evaluate where the vendors stand. So as part of the AI bake-off with NYPA, they gave us a certain set of images and to all the other vendors as well. And they gave us 30 minutes to analyze those images. As part of the AI bake-off, they already had gone through the images and figured out which conditions were bad for which towers. So we went through the whole process. We delivered the results back to them in 6 minutes with all the processing. And as part of that, we came on top at that bake-off, and they were able to deploy our systems. So after the AI bake-off was completed and they highlighted the vendors that they want to work with, they also wanted us to go through an IT and cybersecurity governance. So that is critical for utilities. We are dealing with critical infrastructure data that comprises of images, any kind of metadata with those images. So in order to deploy those systems with vendors, it is really critical that the cyber governance, data governance, and IT systems are put in place. Beyond that, once those systems and processes and frameworks were put in place, we also went through a pilot project. So this was a 1-year pilot project where NYPA gave us data sets from multiple different structures that they were capturing with the drone program. And then we ran our AI models, and they were able to capture key metrics and KPIs on those data sets. Beyond that, NYPA's goal is to centralize, as Caitlin mentioned, they have to centralize their data strategy. So I'm going to talk a little more in detail in the further slides, but starting off, they wanted to build a media management program, and this is a media management platform. What it does is it centralizes the data, the images, any kind of metadata with inspection images into one single location. And a lot of utilities are starting to do that now as well. Likes of Dominion Energy and other utilities, they are building these centralized image management platforms. So in the case of NYPA, they built that image management platform, and we were able to integrate with that platform using our APIs and then also our software platform. And then on the downside, once the images have been processed, we also wanted to integrate with their asset management systems and work order management systems. So NYPA uses IBM Maximo. So we integrated our insights back into their work order management systems as well. And then once all these frameworks were put in place and processes were established, now that's where NYPA is scaling with us. So they have been scaling with us for the last 1.5 years. We are continuously running imagery from their drone programs, processing them, sending it back to their work systems. And that is streamlining and automating a lot of their manual processes on the inspection side, also delivering a lot of value to them. Just to highlight what this program looks like in terms of our software platform. So our software platform is called Power AI. The core technology of it is resting upon computer vision AI. But at the start of, even before AI, how do you manage this massive amount of data? So I mentioned media management platform, image management platforms are the start where we get the data into our system, but we also map that imagery to their respective geolocations. So mapping images with GIS is a critical part of our platform as well. So we work with partners like Esri. We use image metadata, which establishes where the images were captured from the drones. We triangulate those images to their structures, whether it's transmission towers or distribution poles, and we map that on an Esri ArcGIS map. So now we have solved the problem of what kind of images were there and where they're located with their assets. So mapping images to assets for utilities. Now we can actually go into the condition assessment of assets. So this is where our proprietary models come in, and I'll show a few examples as well. But we are looking for condition of conductors, towers, bird guards, insulators. So detecting the components itself first, and then honing into the condition of those components. So once we've detected insulators on a transmission tower, we also want to look at the conditions. So looking at if they're broken, if they're chipped, if they're flashed, and we have a whole variety of different components in our AI library that we provide analysis for. And then once the analysis is done, we like to get this mass amount of information back to the utilities in an actionable format. We don't want it to be just sitting as information on servers. We want it to become actionable. So in that regard, we integrated with NYPA's IBM Maximo system. So now these conditions of the assets are prioritized and being pushed to their work management or asset management systems. I want to highlight the importance of a centralized media management platform. As I mentioned, NYPA developed this in-house, but there's areas where utilities can come together, share knowledge and learnings. But some of the challenges without a centralized media management platform that hinders AI analytics downstream is, if there's no centralized media management platform, mass amount of data that is captured from inspections, the siloing of that data starts to happen. So there's data sources sitting on hard drives, SD cards, private servers, and that doesn't match or mix with the analytics program. So data siloing if there's no centralized image or media management platform. The second thing is metadata associated with all these imagery or videos or any kind of visual data points, that is mismatched. So a lot of times we see the GIS information is not mapping to the imagery, or there's asset information from the imagery that's not mapping to the SAP or asset management systems. And without a media management platform, those challenges still persist and become even more prevalent for utilities. And obviously, because of all of these things, there's lack of advanced AI and analytics missing as well. So without a centralized media management platform, the models won't perform at the same level. The AI analytics won't give you the right amount of information. But now with the benefits, again, it automates the data ingestion. Your imagery is cataloged and tagged at the right location with the right asset. It streamlines the whole process of AI analysis pipelines, which we are doing right now. Easier to deploy APIs, easier to deploy into asset management systems, work order management systems. And lastly, it gives the utilities faster time to insights. So now they know what kind of problems are happening, where they're happening, and what can they do about it. One specific area that we help NYPA on the inspection side of things on the transmission infrastructure is quality assurance. So we build an AI framework where it helps the utilities to capture data the right way. So the problem statement for NYPA was the image quality was inconsistent when they were doing these drone flights. Blurry images, low contrast, low lighting, duplicate images. That was causing a lot of problems on managing this image repository. And also the imagery was misaligned with how the AI models would run on them. So lower accuracy was found on these imagery because they were not captured the right way. So what we did was we established a right standard framework for capturing the data. So we built an AI model and an AI process where when the drone pilot goes out in the field and we get the data back, the AI runs its first pass filter, which is quality assurance on the data, and it tells, okay, this image is blurry, it has low lighting, it's a duplicate image, it has not been captured at the right angle of the camera, it's not right resolution, and it gives out a score. So it's a feedback loop for the drone pilot. So next time they go out in the field, they can fly the drones effectively, capture the data effectively, and now not only are we getting volume of data or images, we're getting quality of images as well. So again, the benefits are, there's reduction in manual review time, so which is 70 to 80% for utilities. It's faster ingestion of data into analytics and media management systems. You also get higher accuracy of the models, the AI computer vision models. And lastly, the quality is what's important. The data quality improves quite significantly. Some of the examples over here, what the quality assurance AI looks like. So as you can see, there's a zoomed out shot of the tower and then a zoom in shot. So one of the standards for that was capture a zoomed out shot, then a zoom in shot, which captures the context. So looking at the belts of the insulator. And as you can see, there's two examples over here. So what the west-facing zoom is, what the east-facing zoom is. In one of the examples, you can see there's lighting on the right side of the image of the zoom-out image. the lighting is, the contrast is bad. You can see that clearly over there. So there's going to be a feedback from our system which will say that, okay, this gets a score of 7.5 out of 10, and this is where the areas of improvement for the drone pilot is. Now, once the images have been ingested into our system, they have been rated, we are now getting quality images. That's where the AI analysis piece comes in, and this is the meat of the problem for them. So not only does NYPA want you to know what kind of equipment or components are out on their infrastructure or assets, they also want you to know what's the condition of those equipment and components. So as you can see, here's a few examples of different kind of insulators, grounding wires that are broken. So what we did was, step one, we detected the component, so we localized the component from the AI model. So the AI model is looking at insulator, a specific type of insulator, whether it's porcelain or polymer or glass insulator. Now, once the model has identified its localized component and it knows where to look at, then we go into defect and anomaly detection. So now we're looking at, okay, this is what an insulator looks like. Let's see what are the problems on it. So here's a few examples that we found where there's broken bells on the insulator, as you can see. There's a wire that's broken. There's some flashover examples on insulators. And we have a whole variety of different problems that we found, not only on insulators, but corrosion, bird guards, conductor sag, in certain degrees vegetation, mostly on distribution, but also right away for transmission as well. Once the analysis is done, we like to involve the subject matter experts into the picture as well. And this is a critical piece of the AI program that we develop in NYPA and certain other utilities as well. This process is called human in the loop review. So as you can imagine, AI models are not 100% accurate. They are learning systems, so they improve with time and data, but also they improve with humans guiding the AI model to success. So what this system or tool does, and it's a tool in our software platform as well, it takes feedback from users, which are subject matter experts. We're talking about field engineers, linemen, field technicians that have this knowledge with them that they can help the models train better, become much more personalized, become much more accurate. So one example over here is AI does its first pass on its predictions. It highlights assets and areas where there's problems on the equipment. Now the subject matter expert can come in, provide that human in the loop review. So maybe the model missed something or a crack on an insulator, or it missed an insulator entirely. They can highlight that. And all of that feedback is being captured by our backend system. So the AI is continuously learning. The algorithms are learning. They're picking up from the feedback. And all of that system is we call active learning. So it's continuously training, learning. So next time a lineman gets an image which has broken insulator, the model remembers that we got this feedback and it got penalized. So it learned from the whole process. So it's a very robust system. The utilities love it. They also have more control on the predictions and analysis. So it also helps them kind of have quality assurance in the predictions or analysis data. But the piece for us is it also gives us a lot of information to work with. This has really helped us, scale our AI models. So we went from, 28 different models to now we are at 45, 50 plus models. And this kind of system actively helps us build newer models and newer capabilities as well. Just to high level talk about where NYPA is focusing on their AI advanced analytics program. So obviously the robotics is the core. So they have multiple drones, over 100 drone pilots, large volume of drone vehicles that are flying continuously. I think they're capturing around 100,000 images every month. So that's massive amount of data, petabytes and terabytes of data that's coming to us on a monthly basis. But the goal for them is to find out the asset health and predictive maintenance around their infrastructure. So assessing the asset health using our system, but also overlaying GIS and asset data that they're capturing from other sources so that they have a better mapping of the areas or the infrastructure that needs maintenance. It also is improving worker safety for them, which is critical. So NYPA has had multiple helicopter crashes where they had to transform their helicopter program to a massive drone program. So they're doing most of the inspections with drones now. So this also helps with worker safety. One of the key things with our system is conventionally linemen and field technicians had to climb a tower up and down, look at various kind of areas, focus areas that could need maintenance. With our system now, they don't have to go to every single tower. They know which towers to go to ahead of time, and they know which problems are happening because the AI has done its analysis. So it also makes their operations more efficient, but also keeps them safe. So every time they climb up and down, they're putting their lives at risk. With our system, that minimizes that. Obviously, they are also trying to do modeling on their transmission infrastructure, and as I said, they are looking at multiple data sources. Our data source is one, which is on the imagery side, but SCADA and other sensors that are put out, dynamic line rating. So other data sources are also feeding into their central analytics engine that they're building. It helps with their engineering teams, as I mentioned, field technicians, field engineers, and then it also helps with risk and compliance. So what they have done is piloted these advanced technologies, and they're learning and scaling at the same time, but they're also keeping risk and compliance in the picture as well. So helping develop compliance, obviously risk for worker safety as well, but compliance metrics, they're tracking those metrics and monitoring them over time also. And lastly, I would just highlight, I showed some examples over there about the NYPA AI use case, but overall it is a really cutting edge use case on how images speak 1,000 words for utilities. So not only are we capturing the image of an asset, but we are also monitoring when it was captured, so temporal features and geospatial features. So now with the identification of assets and then the image analysis for condition assessment of assets, we are also tagging the geospatial element. And over time, our goal is to capture more historical data. With that, we can build more predictive models in the future. So as you can imagine, degradation of equipment happens over time. Our goal is, once we are getting this volume of data over time, which is temporal features, and we're mapping with geospatial, we can predict in the future, eventually, with a statistical likelihood that, hey, we have seen in the past tower X, Y, and Z, malfunctions, at least twice a year. So there's a 75 or 80% statistical likelihood that it would also malfunction in this season. So getting those insights back to utilities also helps them find hotspot areas where they can focus on first instead of going to every single tower for inspections. So again, efficiency increases quite a lot for them, both on the operational side, but also, as I mentioned, worker safety as well. Caitlin, you want to talk about some of the key takeaways?
Sure, thanks. So now I want to transition to talk about the key takeaways and value that NYPA has continued to see from this program, but also how other utilities can engage in similar types of programs to see value. Efficiency is one of the, obviously, the biggest takeaways. So efficiency means several different things to several utilities, but one of them is they're able to scale a large number of inspection image collections and also see insights very quickly from this program, allowing them to take faster action on the mass amount of inspection data that's collected. Also, by automating the workflow tied to it, it further increases the efficiency. What I mean by that, instead of having all of these results analyzed, put into a report, that then someone has to go and manually update the systems of record, NYPA has been able to use their media management platform to streamline all of these different connection points so that they can have data flow exactly where it needs to go to either update the system of record or to ultimately generate a work ticket so that someone can take action on these insights. That further bolsters the efficiency of the program so that they continue to scale at faster rates. The second is accuracy. Computer vision AI detects defects and anomalies with precision, high precision, and recall. One thing compared to manual analysis, where the subject matter experts or the field technicians would just be drawing bounding boxes on critical defects, the AI algorithms are also looking for good components as well for asset inventorying and condition assessment tracking over time. And they're doing so with high accuracy. So not only are you getting the speed to insights of defects, but you're also able to get high accuracy and results for good component detections. That's helping utilities like NYPA with things like capacity planning or with proactive equipment purchasing, understanding where or how many new insulators they need to purchase, how many new cross arms may need to be purchased, or whatever their specific, I should say, procurement programs may be. Don't know. The other thing is safety. So minimizes field exposure. Vic touched on this a little bit, but enabling remote and autonomous operations. By conducting more aerial inspections, you're actually able to see many critical defects from the top down of the tower instead of having someone climb the pole every time. With this, it's valuable because when someone does climb the pole, they know what the severity is of the anomaly that may be at the top. Whether that's a critical insulator defect, whether it's some sort of a crossarm damage, whatever that may be, they're able to know and have more informed pole climbing efforts when they do scale the tower. Also, by using computer vision technologies and AI and machine learning, they've been able to scale their drone program at an accelerated rate, which has helped them reduce the total number of manned helicopter inspections that they have to conduct. And then also scalability. So I know we've kind of woven this throughout the presentation as well, but scalability is key, and it's really multifaceted. So integrations with utility workflows, the GIS, APM, work management proves the scalability of solutions, but really it's multifold. It's how can the utility, such as NYPA, be able to scale their drone inspection program so that they can see faster ROI on that program. Their ability to collect more, get out in the field and inspect more, and then get faster insights also allows them to take better action on those on the insights that are derived, which is helping them get to scale faster. The other thing is because of this media hub that they've built, all of the data sources, whether it's visual, whether it's sensor data, are all flowing into one central platform that allows them to take more informed insights and more informed actions on their maintenance efforts, which is also helping them further get to scale. I want to touch a bit more on efficiency and scalability specifically. So how can you measure the impact of automated image analysis? It can be measured in multiple ways. So time to completion, of course, that's a common one. How fast can you go out and conduct the inspection? How fast until, or how much time has passed until you have the results of that inspection? And then how much time has passed until the work order has been generated and action has been taken? We also see reduction in O&M costs is significant. NYPA has been able to capitalize a significant portion of this program, which is, especially in a tightening O&M environment, has been quite impactful for them. Increasing in inspection capacity, as you'll see the numbers presented earlier of the number of missions they've flown, they continue to drastically increase those missions year over year, and that's largely due to the ROI that they're able to show from that program. And then resource requirements. The combination of drone technology and image analysis is acting as a workforce multiplier and a workforce enhancement. AI is not meant to come in and take away jobs. It's actually meant to help streamline the mundane and manual practices so that those current labor resources then can be applied to actually prioritizing where maintenance crews should be sent and help them get out in the fields and conduct more maintenance. So all of these are common benefits that they've seen, and we've worked with NYPA and many other utilities to help quantify and calculate some of these impacts, so certainly happy to talk through any of those further. And then moving into the value proposition, at a more strategic scale and on a more executive level, how has this further helped the organization? So one, operational excellence has been a significant value proposition. That means operational efficiency with standardization and optimal condition-based maintenance. We often hear, and I think it's been a common theme here this week, is strategic asset management, or moving from reactive maintenance to more proactive maintenance. These types of programs and approaching it in more of a programmatic way helps unlock the further benefits that can allow a utility to move to more targeted maintenance or more condition-based maintenance as opposed to just a time-based or series-based inspection and maintenance process. The second is asset reliability, supporting predictive maintenance, asset life, and asset performance decision-making. Again, this really ties into the first one as well, but the ability to correlate improved maintenance and expedited maintenance as well as more preventative maintenance is further benefiting reliability metrics, especially safety metrics for multiple utilities. Improved compliance, so audit reporting with digitized regulatory inspections and record keeping. Again, being able to have a baseline of healthy assets and assets with defects is a value of using drones plus the AI as well. So being able to say, okay, 6 months ago, a year ago, I saw that this insulator was good and now it's flashed, or this insulator had no issues and now there's a broken bell. You're able to track the healthy assets over time, see how they're degrading, and have a better understanding of where your biggest risk exposure is with your asset management. And then be able to proactively send crews to go inspect on a more targeted basis so that you can then continue to preemptively maintain those assets. And then lastly, it's enhanced efficiency and safety, which we've touched on already, but supporting enhanced worker safety, physical security, and event response time as well. So what are the key takeaways for utilities who are evaluating these types of programs from RFP or from early days of evaluating when is the right time to bring in these programs? How do I go about evaluating this type of program? How do I start it? What are the things I should be considering? Some of these are benefits that we've seen NYPA has done particularly well from even day one of them evaluating this type of a drone and AI type of program. The first is joint innovation, accelerating ROI and adoption. So the partnership between Buzz Solutions and the New York Power Authority has really been truly that. It's not meant to be a point solution. It's a continued learning and evolving program, starting out with finding key wins and quick successes, and then being able to scale over time. As Vic has mentioned, the standardizing and centralizing of data collection and also data storage has unlocked further gains for them. So by thinking about how do I centralize all of our data into one specific location, one platform, has allowed for reduced redundancy in data collection. It's allowed for reduced data siloing across the organization. And then it's allowed companies like Buzz to be able to plug in and provide those enhanced insights all in one specific place, and again, to help them unlock additional gains. It's shared learnings, which has helped improve the accuracy, trust, and reliability in the AI systems. When we first started with some of these programs, we're often working with folks where it's their first time using a software platform as a part of their day-to-day operations. And oftentimes there's a lot of maybe fear or hesitancy of, how am I going to deploy this AI solution? Can I trust it? How am I going to, trust it to provide me the insights? And historically, I've been looking through all of these data sets manually. Well, that's where the ability to be kind of a partner is particularly valuable. To be able to show that the algorithms can have high accuracy over time. It's leveraging tools like human in the loop that allow the subject matter expert to be the final decision maker, as opposed to the AI just taking over entirely. It's allowing the subject matter expert to continue to provide their insights. So it further builds the accuracy of the algorithms, and it also bolsters the trust in these types of systems. And then being a core part of the workflow means that this is not a standalone platform that they have to log into or be trained on. It's actually a part of their pre-existing operations. Integrations with the, as I just mentioned, the integrations with these systems, GIS, EAM, ADMS, ensures streamlined operations, which again helps it be a core part of the workflow as opposed to a standalone practice that they have to follow. And then the ability to measure quantitative and qualitative ROI as a part of these drone and AI programs. ROI can look very different depending on the goals and outcomes that each utility is trying to accomplish, and we will work very closely with many of our utility partners to help understand, what are the key, what does ROI mean to you? Is that improved reliability? Is that reduced cost? Is that proactive maintenance? Really, that can be different for each of the utilities. I know we touched on one specific to NYPA, but again, as you're looking to evaluate these types of programs, ROI is not a one-size-fits-all. It really can be different based off what the outcome is that you're trying to achieve. And so how you calculate some of those impacts and how you quantify those can be different. But day one, as you're evaluating these types of programs, understanding what is the outcome you're trying to achieve and what variables do I need to be looking at or calculating in order to track that ROI is where we've seen other utilities have significant value. And then lastly is being able to show success on small projects and help them scale. One of the things that NYPA did really well was they started with that evaluation that Vic talked about, where they said, we're going to give 200 images, and we're just going to have you process those images and see what results you can return. We're not going to tell you what detections you should be looking for, what are the severity of the defects that are in those. We just want to see what those results are. Well, that quick win allowed them to say, okay, we're going to get a baseline of what the algorithms can do. What is the accuracy that they have today? And then how can we work with that platform to be able to see greater accuracies over time? That helped them to get early buy-in from some of their stakeholders so that they could then say, okay, well, we're going to start with 200 images, then we're going to go to several thousand images. Again, starting small and then building on scale has been something that's worked quite well for them. Another, I'll just add one more thing too here is some other utilities we've seen do this really well. They've started with one or two particular component detections or defect detections that support a specific capital program. Then they're able to prove high accuracy and really good detections on that specific component, which has allowed them to get more interest from additional capital programs. They've also continued to scale by using analytics to support a large number of their capital projects over time. So again, this is an example of starting small, showing the quick wins, can be different based off each organization. Workflow integrations can be another one that's different by each organization. But again, being able to start with a small and focused scope and then scale over time, we've seen be quite successful. And so that is our presentation. I don't know why my last slide's not up, but we'd love to open the floor to any questions you may have. But yeah, thank you, everyone. Thanks. Oh, I just put them. Oh, yes, sorry.
Trying to think how to ask. How, with the data that you get, I'm sorry, I'm butchering, but
Yeah.
how does that talk to us and tell us, and it gets shared in the organization, this data, and then the results, and then the actionable work that it comes from? How does it communicate, and does it automate that in certain ways?
Yeah, no, that's a great question. We want to get to automation, but we still have gates, manual gates in the process, because we want to still keep the human or subject matter expert making the final decision. The goal is, and the best analogy is in healthcare, with radiologists used to look at the scans, and now they get all that information in front of them, but they are the ones making a decision that this is a tumor, this is not a tumor. Same is the case over here. So with the AI analysis piece, we give them all the information. So this is an asset, these are the things or attachments on the asset, this is the condition of those components, this is where the asset is located, this is the time when the asset was inspected. So all this information is in front of them. And also we give the severity metrics, but the subject matter expert also has the capability to change them. And we see them quite often. Utilities on the East Coast might have different severities for, let's say, corrosion or rust on steel structures versus ones on the West Coast might have different. So there's subjectivity over there. So we give them the power to kind of manipulate that also. So, but once they have done that, now we have the APIs or connections, integration points with their GIS systems, with their asset management systems and work order management systems. Now, once they have given that final say, we can push it to those systems, and then that record becomes part of their system of record. And that is the one that gets updated over time. So all these records are tied to the GIS, asset IDs, any other identifiers, and then we layer on the condition of the assets as well.
Gentleman on the human in the loop. So, is it fair? Does the human look at every single image? Does it look at a summary of a poll? How do you save assets when the human's always in the loop?
Yeah, no, yeah, that's a great question, and I should have explained it more. So they look at a percentage. So let's say before a human had to go through 50,000 images. That takes quite a lot of time. The human eyes get strained, and that's where human error starts happening. So after I think there's an estimate after 2 to 3 hours, looking at toggling through images, your error starts increasing exponentially, human error. What our system does is automates that. So now instead of them looking at 50,000 images, they only have to look at, let's say, 150 or 200 images. And those 200 images are filtered out based on how confident the AI is. So if there's lower confidence, we will highlight those images for them that, hey, the AI is not that confident, please take a look. Or if those images have really critical anomalies or defects that need to be fixed right away. So you saw that image where the lower bell of the insulator is broken. So that's a critical problem. So, hey, take a look, the AI found something, and now it's a critical problem. Do you justify that it's critical? Say yes or no. So that's the delta time saved on looking at 50,000 images versus 150 images. That's quite significant when they're scaling programs. And we have seen massive efficiency gains over there, both for time, resources, and cost. Any other questions? Great. Well, this is our information. Please reach out if you want to learn more about NYPA and other utilities we're working with. We have case studies, happy to share learnings and pitfalls as well. But thank you so much for your time.
Thanks, everyone.